now on our last topic, no, the very last topic for elective science 8, no, chemistry, which is the gas laws. No? So here in gas laws, we'll be dealing with conversion, no, conversion, meron mangyaring conversion, different gases, no, that are involved, the different individuals who are responsible. Our objectives, no, for this topic is the first one: describe the kinetic molecular theory and explain the properties of gases. The second one: show the relationship between temperature, pressure, number of moles, and volumes of gas. Solve problems applying the gas laws. And of course, the last one: relate concepts learned to real life situation. So let's deal with the objective number 1. So the kinetic molecular theory. So this is proposed or theorized, no, by Rudolf Clausius, James Clerk Maxwell, and Ludwig Boltzmann. So the word kinetic is derived from the Greek word kinetos, meaning movable. So kinetic molecular theory shows that the moving molecules of gases affect their physical behavior. So ito yung postulates ng kinetic molecular theory. The first one: a gas is made up of very small particles or molecules which are continuously moving. So as what we have observed in our environment, if there's a presence of gas, for example, in in a state of smoke, no? So smoke na lang as an example. So diba, we can see that the smoke is moving since the air is the environment, no, has the factors that makes it move. But looking at it thoroughly, no, so gases are moving. As gases move in random motion, they collide with one another without losing energy. So with that movement, they bump into each other, but take note, energy is not lost. They undergo elastic collision. The third one: gaseous molecules are as far away from each other as possible. Their intermolecular forces of attraction are very weak, regarded as almost insignificant. So, yan, they are positioned in a way na they are far away, from each other. The average kinetic energy of gases is directly proportional to temperature. No, it increases, no, the kinetic energy of gases also increases. So this is the kinetic molecular theory, wherein it describes how gases, no, is being observed, no, or being what do you call this, being observed towards different factors in the environment. So I have here an example, so of which of course relates to gases. So this portion right here, it shows the effect of pressure and volume of a gas. So imagine these two kids sitting in a balloon. Okay, the balloon on which the chubby child sits is compressed to a greater extent than the one in which the skinny child sits, because the external pressure in the first balloon is greater than on the second. So if we compare, no, what do you call this, the volume, no, to a specific to pressure, no, of a gas, so they are directly affected, no, by or with each other. Okay, so on the next example, so we have here the relationship between temperature and the volume of gas. So take note, or I don't know if you observe, no, if you bring a balloon, no, in a specific sunny na area, so eventually though it will not pop, no, immediately, but later on it will pop, no. So if the gases, no, inside the balloon, if it is exposed to sunlight, it will expand and expand, no, due to high temperature, and then it will pop. Okay? So that is, kumbaga, the real life, no, din na mga examples of the relationship of gases towards pressure and volume. So these are on this part, we're gonna be discussing regarding the properties of gases. So number one, gases are readily compressible. So yeah, if we have a specific container, just like on this example, no? So you have our cylinder, and meron tayong piston that pushes, no, pababa, no? Our gases are readily compressible since they are not somehow occupying space, no? So application of an external force to a gas sample confined in a cylinder with a piston causes the volume of gas to decrease. So while pushing this further, it will, no, decrease, no, the volume of gas. Okay. Number two, volume of gas refers to the free space available for compression or molecular motion. So, kumbaga, the space, no, that the molecules can somehow move. Therefore, volume of gas is taken to be equal to that of a container. So, on the previous example, you saw na the more it is compressed by a piston, the more na lumiliit yung space. No? So, kumbaga, the whatever is the space na naiwan, now that is considered the volume of gas, not really the actual space that the molecules occupy. Number three, change in temperature changes gas volume even when pressure is unchanged. Okay, so the volume of gas can be changed by heating or cooling even when the pressure is unchanged. So, of course, because of high temperature, no, it can cause movement, no, or expansion of the different gases that are present. So eventually, it will affect, no, kumbaga temperature, no, can affect the volume of a gas. Next, densities of gases are much lower than densities of the same substance in a solid or liquid state under the same condition of temperature and pressure. Though same of temperature and pressure, but since it is liquid or gas, which we can somehow limit, no, the amount, no, though according to the description, these are all equal, no, equal lang yung kanilang amount, kumbaga. But since gases is freely moving, no, so it can occupy more space compared with liquid and solid. Next, gases are miscible or can be mixed in all portions, no? So it can somehow tawag nito. So example dito is we have blue, red, and yellow, no? It can be still, no, transferred into the same size container, no, and they are they just mix well with each other. Miscibility of gases, unlike those of liquids and solid, is not affected by polarity. So, when you say polarity, it is meron tayong head and meron tayong tail, no, which is yung isa is, for example, in water na situation, water-loving yung isa is water-hating. No? So, and on the case of gases, no, they just freely combine or collide with each other. Number 6, gases are less viscous than liquids. So gases offer lower resistance to steering compared with liquids. So imagine steering an empty, now though we look at it as an empty glass, no, but with gases, so imagine, diba, there's no resistance, no, na nangyayari. But of course, when we compare it with the liquid, eventually merong resistance, and that would somehow limit, no, the steering pressure. Okay, so